Dictionaries. In this video, we will learn about key value pairs and the dictionary data structure. We'll start this video off by defining dictionary as a data structure that stores key value pairs. Now, what do I mean by a key value pair? Well, to understand what that is, let's first consider the list data structure. As was learned in a previous unit, values in a list are accessed through their index. For example, if I want to access the first value in the list, then I need to type the 0 index. If I want to access the second value in the list, then I need to type the 1 index. So on and so forth. So, in essence, in this situation, you could almost think of the index and the value associated with that index as a key value pair, where the index is the key and the value associated with it is the value. The only thing preventing us from calling it a key value pair is because there's no special relationship between the index and the value. For example, the index 0 and Lucy. The reason why 0 is associated with Lucy is simply because Lucy happens to be the first value in the list. That's it. If we were to move Lucy to another location in the list, it wouldn't keep the same index. It would have a new index. Same with the number 1 in James. The reason why 1 maps to James is because James happens to be the second value in the list. If we were to move James to a different location, it would not keep its index. It would have a different index. For these reasons, you will generally not see indexes referred to as a key in computer science. That all being said, imagine if instead of using indexes to access a value in a list, that list allowed us to use ID numbers to access specific values in the list. For example, suppose Lucy had 113462 as a student ID. This would be an example of a strong key pair relationship, because if I were to move Lucy to a different location in the list, that's not going to change Lucy's ID number. Just like if I were to move a student to a different seat in the classroom, his student ID number would not change. Or if I were to transfer this student to another class or in another period, that student's ID number would not change because the relationship is stronger than that. This is the perfect example of a key value relationship where the ID number is the key and the student name associated with it is the value. That all being said, lists do not store key value pairs. With a list, the only way to access a value is through its index. However, one data structure that does store key value pairs is the dictionary data structure. So, how do we create a dictionary? We create it with a pair of empty curly brackets. We've already learned in the previous unit, an empty tuple is created with a pair of parentheses, an empty list is created with a pair of brackets, an empty dictionary is created with a pair of curly braces. Then, to create a key value relationship in the dictionary, I would first need to type the name of the dictionary, followed by the key value inside a pair of brackets. Then I would type the assignment operator, followed by the value that I want associated with that key value. And that'll create the key value relationship in that dictionary. I do this for each key value relationship that I want established inside the dictionary. Then, just as with the list, we use indexes to access values within the list, with the dictionary, we use the key value to access values inside of it. In this example, we're attempting to access and print out the value associated with 325842, which just so happens to be Liz. In the next line, we attempt to access and print out the value associated with 543753, which just so happens to be James. Then, in the next line, we attempt to access and print out the value associated with 111111. However, this results in an error. The reason we get an error message for this statement is because we never defined a key value relationship where 111111 is the key value. Thus, attempting to access a value associated with it doesn't make any sense. Henceforth, it results in an error message. One way to prevent this kind of mistake is to use an if statement. Here, the if statement states, if 111111 in names, which basically means If there exists a key value pair inside the dictionary called names where 111111 is the key, then return true. If there is no key value pair in that dictionary where 111111 is the key, then it'll return false. If we do this before attempting to access a value associated with that key, that'll prevent the error message from being printed out. It's worth pointing out that in a dictionary, it's acceptable for two different key values to associate with the same value. Think of it like two students in the classroom who have the same first name. What dictionaries do not allow, however, is for one key to be associated with two different values. This would be like a single student ID number being associated with two different students. That can't work. The same way every student ID must be associated with one and only one student, every key in a dictionary must be associated with one and only one value. Henceforth, that final statement where we're attempting to associate the value Tony with the key 101034, that statement replaces Jim with Tony. Anytime you attempt to associate a value with a key that is already in the dictionary, then the previous value that was associated with that key will get replaced. So far in this program, all of our keys have been numeric type, but that's not a requirement. A key value can also be a string. In this statement, we associate the string value ABC with the string value Annie. In general, keys are heterogeneous. They do not have to be the same type. They do, however, have to be immutable. For this reason, numbers and strings are the most common types used for keys in a dictionary, since those are the most common immutable types. Furthermore, while all the values in our dictionary have been strings thus far, that also is not a requirement. In this example, we associate a number with a tuple. Values, like keys, are also heterogeneous. They do not all have to be the same type. Unlike keys, however, is that the values can be either mutable or immutable. Henceforth, the value can be essentially almost any type. Let's take a look at how our dictionary would look if we were to print it out to the screen. As you can see, each key value pair is listed separated by a comma. For each pair, you see the key followed by a colon, a space, then the value. And all of these pairs are listed within a pair of curly braces. You may have noticed that when printed out this way, all the key value pairs seem a bit jumbled together, and thus it's kind of hard to read. A much neater way would be to print out each key pair on its own line. This can be done using a for loop. In the first line, we see it says for key in names. As you know, names is a dictionary. Henceforth, this is going to generate a list of all the keys that are inside that dictionary. Then assign each of those keys to the variable key one by one during each iteration of the for loop. We can then use that variable inside the for loop. Here we're using in a print statement. I start by passing the key value to the str method to convert it to a string. This is because our key values could be numeric type, and in order to do concatenation with an integer, we must first convert it to a string. Then over here, we use that key value to extract the value associated with it inside the dictionary. Thus, when we execute the for loop, this will be our output.